We are starting a new series related to monitoring of whole infrastructure, either it is on microservices or monolithic based. So we have to understand a key component in this whole series, that is Prometheus. There are multiple uh, applications that are the multiple components we can say that are interconnected with Prometheus to monitor our infrastructure. So I just opened Prometheus IO to give you an idea what is this tool used for, and just click on the get started and go to introduction overview. So Prometheus is basically an open source tool, and Prometheus collects and store metrics as time series data. That is metrics information stored with the timestamp at which it was stored, alongside optional key value pairs and label. It means we can simply store data in this is type of database, and it's a time series database. Meanwhile, whenever you will put something, it will record the time and date. So that will make very easy for us to fetch the data to get the idea what happened in the past. Now we have to, if we go down, we can see there is an architecture diagram of Prometheus, and this Prometheus server contains three basic components. There is a TSDB, time series database, and there is a retrieval service, and there is a HTTP service. Time series database is simply a database, and it's saving everything on the on your hard drive, whatever you will fetch, whatever will be fetched by Prometheus. And there is a pull service, retrieval service, that will pull the different metrics from the exporters. We will understand in detail what are these exporters, how we can install it, and what type of exporters are available. So simply, exporters will provide some information related to some services running on some infrastructure, some resources, just like CPU, memory, disk, networks, everything related to its infrastructure we can monitor. And that will be simply saved in the time series database. And there is a web server running, HTTP server, that is providing two services. One is the API that is used to interconnect with the other services, just like the alert manager and just like some visualization tool like Grafana. We can use this to fetch the data from this Prometheus server database. This HTTP server is also used for human interaction. We can also open the web page of this Prometheus and we can see what configurations are there, what is the health status, and we can also write the PromQL, Prometheus query language, to fetch the data, and we can directly even draw some graphs and see the history of those fetched data from the time series database. So Prometheus is also giving us a dashboard that on which we can see the overall status of any specific requirement we need to fetch from the database. So most popular tool nowadays is Grafana, that is giving us a very handy role-based access control uh, dashboards, and we can generate different type of dashboards. There are pre-built dashboards we will use with this Grafana. So we will understand Prometheus also giving us a web UI that I explain you. With this web UI, we can also directly design our some dashboard. But Grafana is the most important one. And the API definitely we can use and we can design our own dashboard if we want to customize something. So It's mean we are going to understand the Prometheus server, we are going to understand the exporters and the Grafana. So this will be our first step where we will connect Prometheus with these two uh, different components. Further, we also have to, after getting the data in our Prometheus, so if something happen wrong with our data, something means CPU is consumption is too high, or memory consumption too high, or network bandwidth getting too high, or any abnormal behavior that can cause our application downtime, we can set some alerts. This is the most powerful component that we can say, because all the time we cannot monitor the system by its dashboard. It's good to have some idea what happened in the past, but in the real time as a human it's impossible to monitor all the time your dashboard. So the alert manager will come into picture and it will trigger some alerts for us based on the values we define. Prometheus query language we will use to write some threshold that we want to generate some alert. So that threshold will be generate some alert, and it alert manager then will be responsible to send us some email. It can send the pager duty, it can update us on Teams, or different tools who can connect that can notify us to so that we should be informed on time that this is going to be wrong with our infrastructure and we can timely address that issue. So after implementing Prometheus, Node exporters, and Grafana, we will use Alert Manager. Then we will go to this push gateway. Push gateway is very useful tool. You can say this push gateway is just like a caching of some metrics. Whenever I am saying metrics, metrics mean some data that we want to monitor. Okay, so short-lived jobs. What are short-lived jobs? If we have some server that is up and running all the time, some databases, some web servers, anything else, that will the Prometheus will fetch anytime the metrics from those server because those are up all the time. But if there is some service or server that are just instantly triggered and for to perform some specific job, just like we have AWS Lambda function, just like maybe we wrote some script to automatically create the EC2 instance, perform some task on AWS, for example, and then it will be deleted. Or there is some cron job, or there are a lot of other examples. So those short-lived jobs will save the everything in the push gateway, and later on Prometheus will pull from the push gateway because Prometheus cannot directly go to short-lived. Prometheus don't know when this short-lived application will be up and what information Prometheus need to reach to those short-lived application. So this will be our another component that we will connect with the Prometheus. So, and obviously we can monitor our Kubernetes infrastructure, anything. These exporters can be on any infrastructure that we are managing. It can be Kubernetes, it can be a physical server, it can be a virtual server, it can be a hypervisor, it can be a database, lot of things. We will discuss this in detail. Okay, now I have I will implement this infrastructure on my Docker. So We can install Prometheus as a monolithic environment straightforward on a virtual machine, and we can also use the Docker image to run the Prometheus. So I will use the Docker image that is quite easy to set up. So I have set up Docker Swarm, and I have three nodes, and I did the complete training of Docker Swarm in Docker Swarm series. So if you are confused about a Docker Swarm, you can see those videos. So right now I have three nodes, all are manager. One is working as a leader, and right now Docker service ls, I don't have any service. So what I will do, I have to deploy Prometheus on the server. So for this, I created this Docker stack file. We discussed what is Docker stack in Docker Swarm cluster setup. So Docker stack to set up container or all nodes, we have to go to the section where we discuss, yes, monitoring of nodes and container using exporters, Prometheus and Grafana. So in this Docker stack, I will create a single stack file that will deploy the services for exporters, Prometheus and Grafana. So I'm just going to copy this whole stack file. I will explain you in detail. And here I'm just going to remove this older one created. So I'm going to create a directory with the name monitoring, and here I will create a file, any meaningful name we can say like monitor.yml, and this will be a stack file. So this whole stack file contains services. First one is the seed advisor. Seed advisor is responsible to get all the information, all the metrics related to the containers running on our Linux servers. This node exporter is an exporter, specially exporter designed for the node that will, this image will run and that will fetch the information related to the host machine itself where the containers are running to fetch the metrics related to node. Then this is the Prometheus service, and this is the Prometheus latest image we are going to use. And then it will be also set up the Grafana, and these two volumes I used for Prometheus and Grafana because Prometheus time series database need data persistency in case our container failed. Prometheus so data should be retained. So what I used the volume with the Prometheus pointing to slash Prometheus that contains all the critical data of time series database and um, and some configuration files. So the port for the Prometheus is 9090. I exposed this port. I am using this image from the Prometheus repo. And deployment placement we are going to do on one of our node. I can decide any node. So you know my node name first of all. Let me check Docker node ls. So node 1, 2, 3. So any node we can decide, like I will do node 1 will be responsible to run the Prometheus. And here also the placement I will set to node 1. Okay. And for the Grafana, port 3000 I exposed, and the volume for the Grafana I created here will be pointing to var lib Grafana, because Grafana is saving all its dashboards and whatever customization we will do at this location. So it should be persistent. So, and the for the Prometheus, what else I did, I have to provide a configuration file to the Prometheus so that Prometheus should know with what frequency it has to pull the metrics, and from where it has to pull the metrics. So this config file will contain all the information, and this file will be mapped to this location, etc prometheus.yml. This is like the configuration file. So outside on my host machine where it's running, it can be any file name, but inside the container it should be like this. Okay, so this is all about Prometheus and Grafana, and let me just run this. I will explain you then how this the advisor and node exporter is working. So now we have to create this config file. I will create this config file at the same location because I use a dot forward slash in the this stack file, and the example is given everything in the video description. You can see this is the config file I'm going to use. So you can see this in under the global. I use scrap interval being after every 15 seconds pull the metrics, and from where it has to pull the scrap config. So scrap config, there are two jobs. One is for the node exporter, one is for the C advisor. And in future we can have a list of jobs here. And what node exporter is, static config is with targets. So these are my three servers inside this Docker Swarm cluster that will run the node exporter, and node exporter port is this one. I will show you how this will we can also directly see the metrics on our browser. Similarly, the C advisor has port 8080 and all the three nodes. If you are not running a Docker Swarm cluster, you can also run with the Docker Compose these services, and simply you will run the node exporter and C advisor on your all Linux machines where your containers are running. And if you have a simple Linux machine that has some services running without any containers, so you can only use a node exporter to monitor those. So right now, I set up this only for the Docker Swarm, what I set up right now. I have three nodes, that's why I used all these three nodes. So let me just create this file, and now this file is okay readable. So inside our container, any user can read this file. So let me now do a Docker stack deploy C monitor YML, and the name, any meaningful name we can say like monitoring, monitor servers, or it should be monitoring. Okay, so it will create a network, and all the services under the stack will be connected with that network so that they can communicate with each other. Docker stack ls. You can see we have a monitoring stack. It contains four services, and Docker service ls. It has four services, and you can see it's trying to run now. Two out of three is ready. Uh, Prometheus, we are going only on node one, so that's why it's only one, and Grafana is one. But C advisor and node exporter we set globally, so that one instance will run on each node. If I show you the again this stack file, so here you can see the deploy placement, you can say its mode is global. Global whenever you are using Docker Swarm, so its mode global mean run this container based on this image on one container on each node. And these are the volume means looking very closely all the host machine critical volumes. These are read only. And we give the privilege to means highly privileged container that it can look the all the critical base server directories. And this is an environment variable where I used for this image what type of metrics it should fetch from the for the container. I used all, but you can also see in the documentation of the C advisor there is specific CPU, memory, network, and disk related metrics. But I used all, and this is a port exposure. And similarly, node exporter is mounting these as read only, and its mode is also global. Run each instance on every cluster node. If cluster expand with further nodes or any node is removed, so automatically it will scale up and scale down along with cluster. So these commands will run and port is 9100. Now if I go to my browser and I try to open any node, this is my first node, node 1 IP, and I open node exporter. So node exporter gave me a dashboard and it has a metrics slash metrics we can type directly, and all the metrics related to the node are exposed here. These are humanly readable, like you can see, go down. We have two CPUs, each CPU niceness and user value. All the values related to CPU. Right now, what's going on? If I just refresh, you can see the values are changing because when we refresh, it will show the real-time data. So similarly, hard drive status, a lot of everything is given here. Whatever we need to monitor about our host machine. Okay, if I go to second node, it has in its own metrics page, and I gave the same IP and URL and port number in the config file of the Prometheus so that Prometheus should know from where it has to fetch the metrics. And similarly, this is my node 3. Okay, so again, if you are not running Docker Swarm, you can independently run these services, these containers. Similarly, there is port 8080 that is for the C advisor, and C advisor has its own dashboard, and C advisor is a very powerful tool to monitor the containers, and it can monitor Docker containers and Podman containers. If I go under the Podman container, you can see there is nothing ran by the Podman because I am using Docker engine. So if I go to the Docker container, it is showing that on this node, these containers are running. And everything about the container is given here. It has its own dashboard, but our purpose is not to use this dashboard. We have to use the C advisor just to pull the metrics, and it's the responsibility of Prometheus to pull the metrics automatically. And where we define, let me show you again. In this config file, we defined from where Prometheus has to pull the metrics. And this config file we created here. Okay, so I hope you got the idea how these exporters are working. So now we have to open our let me just Docker service ls. So okay, 3 out of 3, 1 out of 1, everything is ready now. So our 9100 port is used to uh, run the node exporter, and I am looking for Prometheus is 9090. We can open 9090 from any node. Since it's running on node 1, we can also run the command docker service uh, ps, and this is the name of the service. You can see it's running on node 1. If we see where our node exporter is running, it's running on 1, 2, and 3, all nodes. Okay, so now I open this Prometheus web page that I showed you here, this HTTP server. And this is Prometheus web UI. So this is the Prometheus web UI. We can write here our Prometheus query language to fetch some data, and then it will show us the graph. And the, right now our target is not to understand the Prometheus query language. We will discuss this in detail when we will do our alert manager, because in the alert manager we must have to understand how to write the Prometheus query language. So here we have to go to status, and in the target, everything we define in our configuration file, we defined C advisor and node exporter, and these ports and IP we define, and these are reachable. So these are all are in up status, and you can see there nothing is down. If any container goes down, that is providing the metrics. And if I just last scrap, you can see 6 seconds ago duration, how much time it took. Just refresh this page, you can see when this will be, when it scrapped the last values. So with this page you should know, and there are no rules we have defined so far. Time series database, status, how many so far records are fetched, everything is given here. Okay, so now we just understand about these targets. This is healthy state. Later on, we will understand what are these alerts, what are these rules. The configuration file we created that we mapped within our container. You can see scrap printer 15 rest of all default value it's using, and here you can see C advisor target, okay, job, and these are the static configs we defined for the targets. And these are targets for our both jobs we created. This is node exporter, and this is, so you can see here the configs, and time series database I showed you. Now just to give you an idea, it's consecutively scraping the values and saving in the database. So for example, you want to fetch anything like, for example, CPU. So anything that is related to CPU is listed here from its database, like CPU machine cores. So just execute this query, so you can see this IP from this port, this instance, and the machine CPU cores are two. Okay, each one has two cores. And if you want to see in the graphical format, it will show in the graph. Okay, and if we want to, it's for 1 hour, and if we want to see 30 minutes, any, because this is time series, we can fetch the information with on the time based. Similarly, for example, memory. So these are all the values we can see related to memories. Memory byte, just let me check what it's showing. It's 2 GB, I think. The tabular format, this is, I think, in kilobytes. So in the Prometheus, we can also generate our graph. Writing a Prometheus query language is a complete syntax. We will understand this, but just I gave you the idea uh, how you can directly look for some metrics. So now we are done with our Prometheus, and we can see it's getting the data, it's saving in the database. If we go in the again the time series status, you can see the values are increasing. Now we have to open the Grafana. Before starting the Grafana, I will explain you about these exporters. Right now, I use only Node Exporter and C Advisor. Both are responsible to provide us some metrics. One is responsible to provide us the metrics related to container, and one is related to our Linux metrics. We can also set up on Windows to export the Windows related metrics that can also be saved in the Prometheus. I will also show you that one. But right now, I am just running on the Linux. So we have, if we just go up there, so Prometheus ecosystem consists of multiple components. So Prometheus server, client libraries, push gateways, we discuss this. This exporters, go to this link, exporters and integration, just read this documentation, you will get the better idea. So you can see these databases, these are all the databases those exporters are available. For example, you are running some Elasticsearch database, Microsoft MySQL database, MS SQL database, MongoDB, any database, Redis database. You want to fetch the metrics of the database, you just need to use this exporter. You need to configure this exporter to connect with that database. I will, in the future videos, I will give you the idea how to fetch the metrics for some database. So that is very useful to monitor your database's health in case your database's performance is slow. So you don't know either this is because of the CPU limit or memory limit or disk IOPS limits or network bandwidth. So these are due to some bad query written by the developer that is taking too much time. Okay, so you can see what happening in the database, which query is taking too much time, why it's stuck. So this is very helpful. Similarly, hardware, they're just like APC, UPS, you want to monitor. We can use the exporters. You can simply use the exporters that will use the connect with the APC, UPS, and you can read the documentation how you can do this. Similarly, big IP products, you can use 40 Fortinet, and NVIDIA GPUs, exporters, and anything you are missing here, you can go to the vendor specific product. For example, you are running some specific vendor specific database, or you are running some special hardware. You want to use the exporter, you can consult with the vendor. They will provide you the exporters, and you can configure the exporter to fetch the information of that device to monitor, and then those values will be saved, scrapped by the Prometheus, and will save in the time series database. So issue tracker, similarly messaging systems, okay, storages, web servers, what type of cloud providers, APIs, okay. So this is very useful tool nowadays used for the monitoring purpose. And exporters are the core component that will provide us the metrics. So I hope you got the idea about the metrics. So far, we just use Node Exporter and we just use C Advisor, and we successfully save in our database. Now I am going to open my Grafana dashboard. Okay, so this Grafana dashboard will be open, and here the default username when you will open the Grafana very first time, its username is admin, password admin. Now you have to change its password. So after changing its password, it will show you its dashboard. So right now there is no relationship or connection in between Grafana and Prometheus. Prometheus is connected with the node explorer. Prometheus is connected with the C advisor by using the config file. But Grafana don't know what has to be monitored. So just go to Grafana and here in data sources. Grafana is a very powerful tool and you can see all these systems you can connect with the Grafana. MySQL database you can directly connect with the Grafana. Postgres database directly with the Grafana to fetch the information. So there are lot of tools you can connect with the Grafana to generate the graph. But here our target is to understand how to connect with the Prometheus. Okay, so this is our Prometheus. I click on the Prometheus and here it's asking how Grafana can reach to Prometheus. So what I will do here, quickly let me run the docker ps command and you can see the Grafana is running here and a docker if I look into my config file. In the config file its name is Prometheus. Okay, so I will ping the Prometheus, so I want to make sure that it's reachable and it's resolving its name to ID, because whenever you are creating a stack, Docker stack, all the services are interconnected with each other because I use the same network for all the services. So Docker ps Docker execute IT. I will jump into this Grafana container ID by using bash. Okay, I am inside container. Who am I? Grafana is ran by a non-root user named Grafana. Okay, its ID is ID command. Sorry, ID. Yeah, its ID is 4 to 7. Okay. Now, if I ping, I don't think so. I have ping. I have ping command. Prometheus. So Prometheus is reachable. You see, Grafana can connect to the Prometheus service by its IP. So what I will write in my Grafana dashboard to reach the Prometheus, HTTP Prometheus, and the port for the Prometheus is 9090. So why I write here Prometheus? Because my service name in the Docker stack was Prometheus. Maybe you can have different service name, you will use that. But make sure once it's reachable. And if I do a curl to Prometheus on port number 9090, I believe I have curl command. So dashboard is shown by, it is giving us some output. It's mean Prometheus is responding on port 9090 to Grafana. So now I have to, I just give this and we can enable the authentication on Prometheus. I have not enabled, I have not used any SSL certificates. So far I just created a very simple setup. So just save and test. So Grafana sent the request to the Prometheus API and it responded and now successfully connected. There is uh, no issue found in the connectivity. Just save and test. It's saved. Now we will go to data sources and we have added one of our data sources Prometheus. So now Grafana is pointing to Prometheus. Prometheus is from my is pointing to Node Exporter and C Advisor to fetch the database. And Prometheus is acting as a centralized database engine that contains all the information. Now, if I go to dashboards, and I go to new, I can create a new dashboard and I can create add visualization, but creation of dashboard is sometime, not sometime, mean it's a difficult job. We can write our own queries here. We define our data source as Prometheus and we can create our own graph. It's possible, but if I again go to the dashboard, I don't want to save this dashboard. Sorry, dashboard discard. So I discarded. So we can generate our own dashboard. Creation of dashboard is a separate topic, mean our own created dashboard. But I can import the dashboard and we can have some JSON that can help us to generate the pre-configured dashboards by some other developers from the Grafana. So for this reason, you will simply go to search engine and search for Grafana dashboards, Grafana dashboard labs. Here you can see a lot of dashboards created by the Grafana community. Uh, you can filter from here, but I can directly search from here. For example, I want to generate the report based on node. You see, node exporter full. Everything related to node exporter metrics, we can use those metrics to generate the reports in the Grafana. So you can see here sources Prometheus. All sources are, these all graphs are based on Prometheus source. But this graph you cannot use because it is Azure monitor. It has a different source you need to add. So all the Prometheus related graph we can use. For example, let me just quickly select this one, very first one. And here it will give you ID, okay? And it's giving you how you can add the config in the Prometheus to read. So you also need to read these informations, mean about this graph and the older version of this graph JSON files you can download. You can download a JSON or simply you can copy ID to clipboard. So this graph has a ID and you can simply paste here the ID that you copied, or you can select the JSON you downloaded. And definitely the internet is running on your Grafana dashboard, Grafana container. That's why it will be able to pull from the internet, from Grafana online APIs, all the dashboards. So if the internet is not working, then you must have to use the JSON. Okay, so now the dashboard is pulled, updated on. This time I believe it used the latest one, 16.735, 19.735. Last year graph published by this user is used. So the name of the graph is node exporter. You can say node exporter, node monitoring. Any meaningful name you can give. Node monitoring. And in which folder you want to create. Right now there is one default folder. You can create multiple folders, and your Grafana can have multiple sources. Right now I just connect with the Prometheus, so this source will be responsible to provide the data from its database. So just import it. It's loading everything. this dashboard is created. Now, if you see here, it this graph went to its Prometheus source, Prometheus, and asked which job you have to provide the node exporters only. So it fetched down on the node exporter we defined in the config file. Data sources default, we are using this one, and we have three hosts. This is second one, this is third one. Everything, if you select any of the hosts, so you can see the CPU detail, how many CPUs, uptime, okay, RAM, and then CPU basics. Right now it's generating, fetching the graph and showing us. And its refresh time I set to 1 minute. You can do 5 seconds, you can change it. Last 24 hours value it will show us. So if I just go to 30 minutes, so you can see Grafana fetch all the 30 minute or 1 hour. Let me do this. So we started at this time to fetch the data. So on this host, CPU information is given here. We can change the colors, all the graphs, the network traffic, disk usage, everything is given here. Now it's up to you how you can use this graph for your presentation. So this was about the node exporter. Okay. Now let me run some containers and we will monitor those containers by using the Grafana, by using the C-Advisor metrics. So let me run Docker service create name of the service. I can say like web1 and replicas. I can say 6 replicas I want to run, and by using nginx image. So it will create 6 new containers. And if I go to my Grafana dashboard search online, here I want to search for C advisor. CAD. So C advisor we can run over the Kubernetes. So far we are not running on the Kubernetes. Docker container and host metrics. It will use both host and containers. I can say here like Docker containers. So Docker container, only Docker containers. Okay, C advisor Docker insights. So any you can try different ones. So all are based on Prometheus. This is based on InfluxDB. So here I'm going to select this one, okay? So these are some screenshots what type of this graph will be. It will show us the disk I/O memory. Let me just copy its ID and go to dashboards. Now we have node monitoring, node monitoring. If I go to home and in the dashboard, we have one folder only. But in the dashboard, you can also create a folder. I'm not creating folder. Simply going to import it, paste the ID, load the graph. It will take a while to pull all the information online. Okay, so this graph is imported. Its name by default name is Seedvisor Docker Insights. We can say it's Docker as monitoring. Under the folder dashboard, okay, and source used to collect the seed visor is Prometheus. It's also mentioned it should be Prometheus. So import it. Now you can see 11 containers are totally running, and which containers are running, and you can select any specific container to see its memory usage. Okay, and the last 3 are registered. I should use 5 minutes. So these you can see 4 containers are running, but I think this graph is not giving us any information on which host we are going to monitor. So we can use some other graph, maybe because you have to do some research work on different graphs because you are using pre-built graphs. So Docker container, let me just copy this. And here we can go to dashboard back and import, paste and load it, and Prometheus import. Yes, here you can see the previous graph was not good. It was not giving us the idea from which node you have to select. So it's showing all the nodes, or you can select any specific node. Only this node I want to see what's happening. So on this node 4.79, this is also not a meaningful, but let me check the CPU usage, the network traffic by these graph. So these are all the containers. Only web 01.5 is running. Let me just go to Docker PS. Web 01, this one is running. Yes, it's right information. So if you just click on this container, it will show the memory and memory information, all the detailed information you can fetch of any specific container running. Similarly, network traffic, CPU usage, receive network traffic. Okay. So so now you got the idea how you can fetch the different graphs and how you can populate in your Prometheus in your Grafana. So now you have 3 graphs. So you can delete any graph that is not in use by selecting this. Simply you can delete this. So in the future videos, I will show you how you can create the Grafana users and how you can assign different users different graphs. Because right now I am logged in with the admin user, and admin user has full privileges. Admin user can delete the graph, even you can delete any specific graph from here. You can edit this, you can modify this. But when you will create the role-based access control with the read-only access, only users can see with their own credentials specific graphs. So this is all about this session. This in this session we just have to cover about the idea about exporters, Prometheus and Grafana, and how to import the graphs. So in the next videos, we will use further exporters like databases, monitoring, and we will definitely populate the graphs of those databases. We will try to understand the Prometheus query language and will create the alert manager to generate the alert in case of some some threshold limit issues, and push gateways. So I hope you got the idea about this whole infrastructure and what is our target to implement in this series.